if you can hear me, could you please read check? I see a few of you checked in already. We have house today, 11 of you guys. Great. I need to hear from Ross. If you can, Ross. Thank you, my friends. Okay. Thank you guys for coming. It's freezing outside, so I think this Brian, my friend, makes me appreciate teaching from my basement. Don't have to go worry about arriving in a weather like this. So I hope you guys appreciate classes and teaching on like I do. If you remember last week, and we always have done, we go through what we have done last week. And last week we went over chapter number 13. And we talked about flexible conduits, different types of flexible conduits, cabinets, and gutters. We have that we will be reviewing tonight. So I'm going to go ahead and review the quiz, guys, with you. Okay. All right. Just watch you guys fishing here. All right. When I say chat, I think you're chatting with me. All right. So what we're going to be doing, guys, my friends, is we'll over reviewing for the cabinets and the gutters. And when we're done, we will be talking about boxes, the interesting topic, conduit bodies, and fittings that goes with the wiring system, conduit wiring system. Before we can start, my friends, let me see how many of you have done box fill calculation. Just give me a green check if you have done box fill calculation. Okay. So it means some of you have done it in school or somewhere else. Okay. Box calculation. How about you guys have installed conduit bodies, that elbows, installed conduit bodies? Yes, no. Fittings that looks like conduit bodies too. Fittings, the fittings. I'm sure a few of you guys have installed them. Okay, so before we go ahead and start, let's go over the quiz, guys, because that's always my goal, to go over the quiz. Number one, so let's go review first the flex, and then we will move into our nice topic for this. Okay, let's go back. There you go. Which is going to be boxes and conduits. Great. Has any question in particular, guys, about quiz number 13 that they want to discuss? Any question about quiz number 13 that they want to discuss? In part, either you can chat with me, you can raise your hand, I can pass the mic to you, or you can just drop me a line here. But, okay, I'm going to go. I highlighted a few of them that most of you guys got them wrong. I'm going to go over all of them. Flexible metallic conduit can be used exposed, bring it on, in concrete, if listed, underground, if listed. So, well, no, not if listed. This is, so the most important one, guys, in concrete, yeah, you might have it listed. Underground, for the most part, you don't. So the most important, this is, and you can argue here, the closest answer is going to be exposed. And I guess you can buy listed, anything can be listed, guys, to be underground or in concrete. But on the requirement based on the rules, which is 348.12, answer is exposed only, and you can submit anytime. Conductor that can be used in any, and I'm going to highlight the word any location, wet location, dry location. So see that key point is any. That's what you get for your master exam, guys. They put these key words. The conductor that can be used in any location. Most of you guys got this wrong. And the keyword is any location. As this baby, for the most part, because THW is wet because of W. So can I use it in dry location? Bring it on. Can I use it in wet location? Bring it on. So what's the difference with these two guys? These guys are, for the most part, dry location area. So that's why our answer was number 8. Any question, guys, about this one? And the keyword is any location, dry, wet. Into the flexible metallic conduit is acceptable as the equipment grounding conductor. This is directly, guys, from the flex. If you go define the flex, first it has to be listed fittings, overcome fixture device not exceeding 20, and the length limitation on the length. So that's straightforward, no gimmicks. So all of you got right. Moving into 4. Number 4, if flexible conduit is not acceptable as grounding means, what shall you do? Of course, you have to install equipment grounding conductor. It goes without discussion. All of you got right. Number 4, the requirement for securing liquid tight flexible conduit 12 inches from the box and 12 inches and 4 in between. You can waive that baby if you are using it as a fixture web, and a fixture web, my friend, is all fixture webs, guys, except which are, I think, 4.5 Romex. All fixture webs are 6 feet. So up 6 feet, no support every 12 inches of a box. If it's used as a fixture web. All of you guys got that one for the most part right. Okay, 3/8 inch, 3/8 inch and an inch, 3/8 an inch and 1 inch rigid inch thread sizes of a liquid. This is the liquid flexible conduit less than 6 feet long are acceptable for grounding purposes if the overcome fixture device is number 6, my friend, is 20 amps. And this is directly, guys, with a limitation in the size, on the size and the length. So you can, up to 20 amps, you can use it as an equipment grounding conductor if there is no flexibility or vibration coming out of the equipment. Otherwise, you have to pull an equipment grounding conductor. The same 3/4 inch and 1 inch sizes of liquid tight metal conduit less than inches. And number 7, guys, it's 60 amps all the way grounding conductor if there is no flexibility, blah blah blah, up to 60 amps. So this is 3/4 inch all up to 1 inch, 3/4 inch all the way up to 1 inch. This one 3/8 all the way to a half, 3/8 all the way to a half. If somebody's wondering why 3/8 all the way to a half, they'll limit you with the 20 amps. If you go to a bigger size, now we went all the way from 3/4 to an inch. They allow you to go up to 60 amps on a branch circuit. Nothing needed and no vibration. Okay, now, all these have been right. Number 8, flexible metallic conduit is permitted to have flexible conduit like any other conduit, but you can't bend that baby more than 360 degrees. No question asked. 12-inch fastening requirement for liquid type flexible non-metallic conduit is waived for flexible connection when the length is not, number 9, our answer, not more than 3 inches for flexibility, but not more than 3 inches directly. And I want to emphasize the word none. This is non-metallic, non-metallic. That one, a lot of you guys got it wrong too. None. I think probably you were not looking at the non-metallic. You were looking at liquid tight, metallic conduit maybe. So number 3. And looking at your chat, guys, if anybody wants to chat about them. Okay, number 10. Also, a lot of you guys got this wrong. If it's a 3-foot securing requirement for a liquid tight, flexible, again, non-metallic, I can't emphasize the word non-metallic, is gone, waived. If it's not longer than, and number 10, not longer than 6, not longer than 6. So a 3-foot securing, that's a 3-foot securing, and that's a 12 inches. Remember, this is a 12-inch securing from a box. The requirement is for the 12 feet securing in between, So there, number 10 is 6 inches. 11. Number 11, my friend, cabinets, car boxes installed in what location must be all of the above. They have to be proof. They have no accumulation of moisture in it, and the moisture does not allow moisture to enter that enclosure. 11, 12. It's what, friends, if you have any all the elements that you need, if the enclosure sits back not more than 1/4 of an inch from a finished surface installed in non-combustible material like concrete, block, tile, and know that this rule applies for a lot of things, guys, for boxes and so forth. So this applies for any and each and every one of them. And some of you guys got that wrong. So basically for units, cutout boxes, meter enclosures, even you're going to today, you're going to guys talk about the same thing. Even pole boxes and J boxes and especially device boxes. So our answer for this particular one was D. Question, guys? Any question? My good. Quick, just when are installed into combustible materials, the front of the enclosure. Now remember, it's combustible, so they don't want anything. If flame and spark and arc inside this box, they don't want it to spread, so they want it to be completely shut by the cover. So our answer for number 13, my friend, was C. I'll tell you why C, guys. Be flush. That's one, or extend out from the finished surface. So you can have it. Here's your finish. You can have it extend, or you can have it a flush, as we all know. And the reason behind this, guys, when you put your cover, your cover will be completely shut down, shut the whole box down. So if there's a fire here, the likelihood that the fire will spread outside the box is nil. The same thing here. The box cover will firmly sit against the box itself and would not allow the arc and spark to exit or leave the box. Okay, so number C is our answer for that one, as you know. A lot of you got this is number 15. A lot of you guys got this wrong, so mark it. 14, enclosures for switches. Pads may be used as a junction box. Can I use it as a J box? No problem. Bring it on. Or for conductor feeding through, where the conductors do not fill spaces at a cross-sectional area more than just conductors passing through. Number 15 is 40%. So I use 40% out of my the gutter, then with my panel, and I pull my conductors. If I have a switch here and I have a lighting fixture right here, and because I'm a lazy and I don't want to go through another J box, I pipe that switch to the light, and I pipe from the switch to the panel, pipe the panel to the light, and then I grab my conductors, my friends, and off I go with my conductors through the conduits right through all the way to the box. Is it okay? No problem, as long as you don't fill it more than 40%. Any questions? Any question about this? And I think we emphasized it when we were going. So there, number 14. Number 15. Slices. Can I slice? No problem. Or tabs are put in cabinets. Switch gears, switchboards. As long as you don't fill more than, anybody remember? More than 75%. If you are to splice, so now I got into another issue. See, I'm going to splice right in here for whatever, bring to the overcapture device, then splice from here and go through this box, through this fixture to another fixture, right? I can see fixture from this fixture to this fixture, whatever. So I splice as long as that splicing does not fill more than 75%. So we killed this horse. Number 16. Number 16 is the auxiliary gutter shall not extend more than how many feet? And that's what makes an auxiliary gutter, guys, not a wireway or raceway. It has a limitation on up to 30 feet. It's an extension of the equipment. So, I mean, 30 feet to extend a piece of equipment. I don't know about you, Joe, my friend. That's a heck of a piece of equipment to extend it 30 feet. So that's it. 17, my friends, is sheet metal gutters are required to be supported at intervals not exceeding, and our answer for this one was 5. Every piece you have to support them. Every piece you have to support them. Some of them, if they're listed, if I remember right, you can go all the way up to 10. But every 5 feet is the norm. Every 5 feet is the norm. 18. 18 is the number of conductors permitted in an auxiliary gutter is limited to that which will fill it to which point? Number 18, our answer is 20%. So if you have a gutter, you're going to see almost as a conduit and not fill more than 20% of it. Everybody that right? This one where some of you guys got it wrong. If you conductor, my conductor is 300 kcm conductor, this through the side of an auxiliary gutter, the width, the minimum width of the gutter at that point is, and we have to do it, and so my gutter, and here's a terminal for this, say there was a terminal, here's my conductors here, and if so conductors interleaving opposite walls, this will be carbon expenses at terminal. Leaving opposite wall. This one, it doesn't say opposite walls, so it's going to give. Let me have a wire like this. So I'm bringing conductors, guys, and I'm moving them this way, right? Coming from side. I can do that. What's wrong with that? Then the of the that I'm using, it's going to be from table. If you go 312.6a, and that will get you based on a healthy based on one terminal, and will get you 5. Okay, question, guys. One more time. Let me just erase you. Make sure you're with me. And question, guys. How about an X for Chad? Make sure that we cover what you want. So the questions were really cool. I got a whole lot of them, guys, but with practice, you continue. Especially this table, guys, I guarantee you, I teach the exam prep for MEA, and test this particular table in the German exam. There is a question about finding exactly the width. It was a width or the bending radius. They call it the bending radius, not the width of the gutter, the bending radius. And you have to use the bending radius of a cable that enter a box from the side. And you're going to go to 310.16 based on one conductor entering, one channel is going to decide it. Okay, basically it. Any question, guys, one more time before we move into topic for the night. So, okay, if you guys, as we know, moving on through the code, we talked. If you guys remember, we covered almost, not almost. We covered a lot of most important wiring methods in terms of conduits, non-flexible, and flexible, and cables, if you guys remember. So we covered all this stuff, and then we moved into the cabinets and cutouts and boxes and so forth. We covered that one. Tonight, raceways, we also covered raceways and wireways and gutters and assemblies. Tonight, we're going to continue moving into direction of wiring methods, wiring equipment, ornament, so to speak. So be using, guys, talk about the pole box, a jump box, conduit body, and the fittings that goes with the conduits. I know I asked you guys, almost all of you guys install them all the time, and talk about the code requirement that governs every one of these. So that's what's going to be, guys, our topic for the night. We will also kind of diverge and talk a little bit about handholds, requirements, and so forth. All right, a couple of definitions, guys, for the boxes. Outlet box. You can, my friend Joe, you can use any box as an outlet box. And you can use a J box with the right fittings and the right ring, as we know. And Matthew, my friend, and you can use it as a J box. But typically a J box will have this definition. So we have boxes, this should be equal or less. Boxes, let me cross them, equal to 100 cubic inches or less. So base 100 cubic inch, and box that's equal or less than that, equal or less than that. Don't look at the equal or less than that. Grab it here, grab that baby. Okay, I'll erase that one. Okay, so equal or less than that, it's going to be for the most part an outlet box. Now, can I use an outlet box as a J box? Yes, absolutely. Not to use, but you can use it. A junction box, anything larger than 100 cubic inches, my friends, is a J box. Now, can I use a J box as a device box? No problem. So this definition doesn't mean a whole lot, because you can use the J box as an outlet box, an outlet box or a J box. But for the most part, a box, you put a device in it. A J box, you terminate for light fixture, terminate conduits into it, connect the phases, switch from one direction to another, and so forth. So, guys, it's mainly meant to provide an outlet there, you know, an outlet, receptacle outlet, switch outlet, any type of a device. If it's a J box, for the most part, it's meant to terminate and in different directions. Line it. So if I have circuit here and a circuit here and a circuit here and a circuit go there and one over here and one here, now it doesn't take a genius to tell you, well, hey, by the way, what if you bring a J box right in here, and then you can terminate these, and you can, you know, you can make them go different directions. You can, you know, particularly what a box is. The box, as you guys, my friends, know, you bring your receptacle over here, put 1, 2, 3 receptacle, you bring your box. Now you utilize the power through device box. Anything else about device box and J boxes? Anything about device boxes and J boxes before we start? Any of them could be used as a J box or device box, but the definition, for the most part, the sticks. All right. Now we know what a J box is. A lot of you guys, I'm sure, have used J boxes all the time. Very commonly used if you use a conduit system. You know, you as we say, you put your J boxes in here in the ceiling, and you run your conduits right in between them. One good way of doing it, and then you put your fixtures. This is just a feeding fixture from all these areas. So if you have multiple fixtures in this area, off you go, feeding all these fixtures directly from this. Let's say your fixture. One way of doing it, I guess. And you don't have to do it this way. So many ways I said doing it. So you can come out of here, and I drew a lot of fixtures here. So here, my friend, and let me just finish these. Off go. Now you come over here out of this device. Okay, that will be a lot of fixtures to feed. So I can probably come from fixture 1 to fixture 2 to fixture 3 all the way. You know, that's allowed in the code. And I can come also from here to here to here and all the way to here with an MC cable. And the same thing, I'm going to come from here. But these I decided to go home run like this, together. I'm just doing different scenarios here. See, here's my MC cable, and I cover here, and these I decided to group them all together for an MC cable. Any question any question about using it? And my box is right in here, as you guys know. And when my circuits come, I can split these three-phase circuits to go in direction, share neutral, and so forth. That's a very complication of J box. Any question about the use of J box? So that basically is my J box. Pull box. Pull box enclosing only conductors without splices. To be a pull box, guys, the conductors have to be 4 or larger. So conductor have to be a pull box. It has to be here's a conductor. It has to be number. This is Mr. Conductor. Mr. Conductor has to be number 4 or larger in order for the box to qualify as a pull box. How many of you have installed a pull box with conductors number 4 or larger? A pull box with conductors number 4 or larger? Okay, these are they act like a pole box, but we use them for feeders. We use feeders. So if you have them, if you have let's just take for example, I have my panel is located right in here. I'm pulling out of this panel, say 400 amp feeder, a 400 feeder, and moving my feeder all the way to this direction, and to take my feeder all the way to this direction and down here and all the way to this panel. Okay, that's just for the heck of it. Now, I might need, and these distances, let's just say this is 50 feet here, and I have 100 feet here, and let's say 40 feet here. So that's a long run, and I have 10 feet down to my panel. So a good application for this, guys, because of exceeding the 40 degrees and all this good stuff, a good application would be if you put a pole box right in here for your conductors. So that's my pole box. Very good application for that. And based on the situation, so you pull your conductors to this point. From point you pull them through the conduits. You might need another pole box right here. It wouldn't hurt at this to put pole boxes, pole boxes in these corners. And remember, we are talking, if it's 100 amp, you're talking about 4 conductors that you're pulling in this feeder, 5 kcm each, 500 kcm. So 4 conductors, 500 kcm each, 50 feet, and then 100 feet, then 40 feet, then 10. It might be a very good idea to put these pole boxes to make it easier for you to pull these conductors, 1 or 2 of them. What you guys about the pole box? So these are not baby conductors. When you have a pole box, you're dealing with large size conductors, number 4 larger. And guys, without splice, that was true before. See, that was without splice. That was true until 2008, as a matter of fact. Now you can splice or in a pole box as a. So what does that mean, Chad? It means, well, let's clear, and let's say the first run I came over here, and then I grabbed another run here, from here all the way up to here. Okay. And my friends, I decided to splice them, splice or tape right in here, and splice tape right in here. No problem. No problem. So instead of him through, I can splice in a pole box, just 2 sections. I have a 550 feet, and then 100 feet, and then 40 plus 10, 50 feet. Pull, then splice them inside the pole box. So I want you guys to ignore that particular one. So you can splice in a pole box. Any question, guys? Any question on the pole box? Boxes also in junction boxes. So really the main reason of a pole box is distance. The reason why would anybody ever have a pole box, guys, and as we said, is distances. And the reason, my friends, is if I have more than 360 degrees in a conduit system, you have to. If you have more than 360 degrees in any conduit system, here's here's the first 90, second 90, third 90, fourth 90. You're done. So my first 90, 90, 90, 90. See if I want to go from this panel right through. I don't want any 90s. You just right through the panel. So there's no. I need to add one more. I add one more here to get down to this panel, right? Now I exceeded this angle here will be exceeding the 360 degrees. So don't worry. What do? You go somewhere in here and you put yourself a J box or a J box, as a matter of fact, depending on the conductor. A pole box or a J box, depending on the size of the conductor. So the pole boxes, guys, the 2 reasons mainly. Length is not one, and number 2 is if you exceed the 360 degrees, and you have to have a conductor large enough. apply the rules of a full box. J-boxes, for the most part, J-boxes are used for smaller conductor. J-boxes, for the most part, is used as conductor will be equal or less to number 6. Number 6. That's defining as a J-box, not a full box. Okay, outlet box connects your realization equipment to a branch circuit through a receptacle. So here's your outlet box. Boxes also there's also device boxes that connect outlet boxes. And in the outlet boxes, you can also have devices, guys, not just circuit breakers. You can switch. It could be a receptacle. It could be a switch. Any question about these definitions of these boxes? How about that? Nobody wants to talk tonight? Okay. You guys are familiar with the square boxes? Huh? Square box, these boxes, we're going to go look at them. Different type of boxes, gangable boxes, round boxes. This picture, as a matter of fact, from our labs are done with it. Very visible. And you see that device boxes that you have over here, different multi-gang device boxes. I'm sure if you guys are doing your apprenticeship, here's a 4-gang device box, 3-gang device boxes. I'm not saying a lot of things that you guys know. Plastic boxes, metallic boxes, and so forth. Square boxes here that you can use. So these, for the most part, are device boxes. Round boxes too. Round boxes. Different type of round boxes. Different type of boxes that can be used as a support fan and so forth. Okay, device boxes. Device boxes, you can have them single gang, 2 gang, 3 gang, and up to what? 8 gangs and more even if you support them right. So if you're not familiar with the ganging, guys, this is a 6-gang device. This is a 3-gang device, a 4-gang device. As you can see, you can put device 1, 2, 3, 4. So 2-gang devices here. Depending on how many devices you can fit in that box. So put in my device, you don't have to split it, but I'm just showing you. 1, 2, 3, 4, 5, 6. I can put 6 devices in this gangable metallic box, and the devices will be, each one of them will be sitting in this enclosure, and they don't have to be separated. Any guys about gangable boxes and non-gangable boxes? Any questions? Now, cabinets, we talked about cutouts and cabinet boxes, guys, but this is just this one that we covered last week. Since we have boxes, so just to throw this box that we covered last week, boxes designed for surface mounting and equipped with a hinged steel-woven cover. So if you hear a cabinet or a cutout box, this is not a J box, not a full box, not a device box for the most part, and it's meant to enclose an overcome fiction device. It's a panel, or a meter box, and so forth. Cabs, guys, enclose it, again, designed for surface or flush mounting, and equipped with means to attach a swinging door. So you get confused between, because they call it boxes and cabinets and so forth. Now, my question for Jacob: can I use a cabinet as a J box? Yeah, no problem. Meaning, can I splice in a cabinet? No, absolutely. How about J box? Can I, and a cutout box? Yes, you can splice in a cutout box if it's an overcut fiction. No problem. We have access to them. And guys, any questions? Brenna, I have to remind you guys that you have to stay with us. Thank you. I see the exclamation mark, guys. I have to, maybe because the Uncle Sam is big brother is watching. Yeah. FYI, I don't count your time, so I didn't mean to be a jerk or something here. All right. Basically, a kind of a quick review, guys, of the boxes. The most important ones, as I said, are the full box, J box, and outlet boxes. At least for the night. Cabinets and cutout boxes, we covered them last week. What boxes that we should be aware of? This article, guys, about switches in particular. If you put a box, a switch box, make sure the top handle of the switch is not 6, 7. For all switches, guys, for over 10 device switches, for snap switches, for 2-pole, 3-pole, any type of switch, from the top edge of the switch down to the floor, it cannot be more than 6, 7. And that's directly for Chad, people like Chad who are short, so that you can extend your hand and push that thing to turn it on and off, or energize or de-energize the equipment if that's the goal of it. Okay. Receptacles, that's a height limitation on how far you can put a box if it includes a switch. Okay. Another thing that you guys need to understand, also receptacle outlets. With outlets, if you put a receptacle higher than 5.5 feet, then the receptacle would not count as one of the receptacle required in the code. For example, if I have my over here, and I decided Chad carried single-handedly to go put my receptacle right in here, and from here down, that was 6 feet. And I need receptacles on the floor, right? By code, you need them every in residential habitable space. You need them every 12 feet in between, right? And 6 feet from edges. So it needs to be 6 feet. Now, the receptacle that at 6 foot high would not count. About this, so beware of these height limitation of receptacles. I call it height limitation of receptacles. The second that very important is American with Disability Act, AA. With Disability Act, there's requirements, and you can find them online and everywhere else. Tells you, because of American with Disability Act, especially guys public areas, especially public places, you have to put I think was it the switches, I think 42, between 42 all the way to I remember 46, somewhere between 42 and 46 inches. They have a limitation, guys, how high range, how high should you put these receptacles or switches to meet the ADA requirement. Joe, if you're wiring your basement, Matthew, my friend, who's doing residential, ADA requirement not exist. If you're in a hospital, a sport arenas, public places where handicapped people, people with a wheel, people with wheelchair can be accessing these places. We want to make sure that that those people can access they'll be able to plug and unplug things. I have these numbers if anybody's interested in them, height of the receptacle and so forth. I can email it to you. I don't have them right at the moment, but I do have the requirements. For the more rough, my friend, other than the American with Disability Act, if I ask you, let me ask you this: where in code is it in code? Does it tell you where in code does it tell you how high you can put a receptacle off the finished floor? Is it in the code can tell you how high you can put a receptacle? How about an X, no, and green check, yes? Anything in the code tell you how high you can put a receptacle above the finished floor. This limitation of you can't use it. The NEC code book. Most of the people get put them inches off the finished floor. That's common. I mean 12 inches of finished floor, and you put your receptacle. Really, if I put them, how about I put my receptacle here at 2 feet above the finished floor? Is there anything wrong with that? There's not any sequence book where it tells you how high you can put your receptacle. Switches, Chad. How high can I put my switch? Can I put my switch at 4 inches or 42 inches or 48 inches? How about American with Disability Act? There's nothing in the code that tells you how high you can put your receptacles. There are recommendations, and a lot of these recommendations came from the American with Disability Act. It's 42 to 44 and so forth. But of devices is not is not other than what counts and what, like two heights are just what counts and what not counts. You can put it higher than that. But I put it 6. Should I put it 5 feet? Anywhere? Any question about that height of the receptacle to American with Disability Act? Height of the devices, receptacles and switches and so forth. I do have them. Okay, firewall penetration. Interesting. You have boxes. If you have, now remember the same thing we said, guys. If you have a wall, a fire-rated wall, penetrate the fire-rated wall with a conduit. You guys remember we said you have to caulk that conduit or seal that conduit with an approved fire-rated equivalent to the rating of that wall. So if this is on our wall, your seal has to be 1 hour rated. If it's 2 hour wall, seal for the most part it has to be 2 hour rated. 3 hour wall, 3 hour rated wall, 3 hours. So equivalent to the wall. The thing is, if you have a box, now if I decided, Chad Kerry, to go put a device here in this box, penetrating requires fire resistant wall or ceiling, the fire resistance must be maintained. So if I put a box right here, I have to go cut right around the box or something right in here to maintain the integrity of this fire rated wall. Anything else? Wall, again, not any wall, a fire rated wall. Now, non-metallic boxes, if they are classified as fire resistance, no problem, permitted. Doesn't have to be metallic. Doesn't have to be metallic. And this ceiling is for fire rating, guys, not for environmental. This is for rating walls. So pay attention to this. Boxes on opposite sides of walls must be separated by a horizontal distance at least 24. So in a fire-rated wall, guys, you know, you my wall. So if you, here's my studs over here. You will put your receptacle, one in this side and one in the other side. This one pointing the other way, and this one is pointing this way, right? So we'll put them in 2 studs in a fire-rated wall, and even if you're going to maintain the integrity of the wall by sealing them, to have to be fire-rated assembly too, or rated wall, approved rated wall. You have to maintain 24 inches. The maintain of 24 inches, guys, like firewalls, only in firewalls, will guarantee you they're not going to be in the same stud, right? This is 16 inches. And 16 inches. So if they have to be 4 inches apart, they can't be in the same stud cavity. That's 24 to kind of guarantee that you don't put them in the same stud cavity. So if you have to put them, guys, back to back and so forth, then you have to put all these mod them in both sides to maintain the integrity of the fire-rated wall, the fire-rated wall. Again, we're only talking about fire-rated wall. A fire-rated wall in a dwelling, and my friend, is an attached garage. The one between the garage and an attached garage and the house, that would be a fire-rated rated wall. Double sheet rock. Use a special type of non-metallic. You have to use a fire-rated boxes in it, and to maintain, you don't put them in the same cavity and so forth. Any question about that? Here's some body pads, gypsum boards to maintain the opening must be protected by a fire barrier. So pay attention to fire-rated walls and penetrating the fire-rated wall. Either you're going to use some type of a putty pad to seal it to maintain the integrity of the fire. Fire-rated walls, Joe, my friend, they're meant, if there's a fire in one area, they will not spread to the other area. So the walls go all the way up to the structural ceiling in the building, unlike other walls where they can go up to and slightly above the suspended ceiling, and they stop. They go all the way to the suspended. Another thing that's not code, guys, but it's smart idea: transmission of sounds. If you're wiring an apartment, apartment 1, apartment 2, it wouldn't be a smart idea to put a box right in here and another box right in here, right between the two apartments. What the noise from both direction, it can go from here to here. So transmission of noises, sound transmission through the boxes shall not be located on both sides of the walls within the same stud space. So these are mainly for sound control, especially if it's 2 apartments. That's the place where become you pay a lot of attention to it. Number 1. Number 2 is also, guys, in a room between a kitchen and a bedroom. If it's back to back, people work in the kitchen and somebody's sleeping. Just pay attention where you space, where you put your. So what do? All piece of cake. All what you have to do, my friend, now is just the same. If you have the same cavity here, studs are here in residential, or other words, you just put one device per cavity, per cavity, both sides, from one. So you put one device from this side and one device from the other side, like we showed here. You do this in the same cavity. Now, devices here. I can in the same cavity here, 2 devices, no problem. But other side, that makes sense for you. Any question about sound transmission, fire rated walls? Very important where you locate your equipment. Round boxes. This is in this article, guys. Very interesting. It says should not be used where the conduit. Now we're using conduits or connectors require the use of lock nuts or bushings are to be connected to the side of the box. And with these round boxes, if you have a connector, it will not sit firmly on a round box. If you're looking for a conduit, lock nuts and so forth, it wouldn't sit firmly in a round box. So round boxes shall not be used where conduits or connectors require the use of lock nuts or bushings. Only the lock nuts and bushings are connected to the size box. So if you're using lock nuts and bushings with conduits, then you don't want to use round box. Any question? Box is your box of choice in this application. Any questions? So that's another important thing about boxes. Non-boxes, and we're going to go, shall be permitted only when open wiring. When can I use non-metallic boxes? Look at that. Open wiring on insulators. Are you kidding me? Anybody still extending? That's a knob and tube. Concealed knob and tube. Open wiring on insulators. Tube. Wire. Okay, non-metallic sheath cable, that's my NM cable. Flexible cords, no problem. Non-metallic raceways, no problem. With certain exception, but for the most part, guys, non-metallic wireways are, for the most part, will be used with non-metallic wire system. Non-metallic wire systems. Any guys about this? Any question about this? Any question? A few exceptions, guys, for it. And if you look at the exception number 1, it says where internal bonding means are provided between all entries, non-metallic boxes shall be permitted to be used with metal raceways or metal armor cable. Where means of bonding, because metallic you can't bond to the device, so you have to provide a means of bonding. Then you can MC cable. Where bonding means with the provision for attaching an equipment bonding jumper inside box are provided between all threaded entries in metallic boxes listed for the purpose. Metallic boxes shall be permitted to be used with metal raceways or metal armor point, if you are to using it, is they want to make sure that the cables are bonded together. You have some type of a means where you can bring an MC cable here, another MC cable here, and you bond the shield of the MC cable to the other shield of the MC cable, not just or AC cable. If you have an AC cable and an AC cable here, and this is a non-metallic box, they're not bonded, so you have to bond the two together. Question is, so for the most part, it's limited to non-metallic wiring methods. Moving guys into the metallic boxes. Number of fixtures of non-metallic. We'll talk about this one. Boxes. Okay, boxes shall be grounded and bonded, as we all know, according to all these articles, with exceptions. So if you have a metallic box, bond and ground and metallic boxes. Bond and or ground. Sometimes the bonding and the grounding happen in one conductor. Sometimes you have to use type of conductors for bonding and grounding. And I'm not going to get into special boxes, full boxes, how you ground them and bond them. A conduit coming guys with a set of connectors from this side, and another conduit coming from this side, and a conduit coming from this side. This is like a J box, not a J box, a full box, your full box. So you might have to bond, and these are not threaded, just a set of screw. And all these conduits to a grounding bar inside your box, which are bonded together. Special box, for example, is a full box that's non-metallic, like a people box or something. Short radius conduit. Short radius conduits or conduit bodies, guys. Closed conductor. Look at the limitation of the conductors. One is number 6 or smaller, only intended to enable the installation of the raceways and the containing conductors. So it comes over here and down here and all the way, and then you have your conduit body right here, right guys, right in the corner. So you do is the cover, you uncover it, you pull your conductors, and you continue. It's like it's where you get you around the 360 degrees. Another conduit body here, you put your conduit body here, so you can pull your conductors and you go down again. Shall not contain splices or caps or devices unless they are listed. There's some, there could be places where you can put splices and devices, as a matter of fact. Shall be sufficient size to provide free space for all conductors enclosed in the conduit body. So you have room for all the conductors that go through it. Handle cabbed, elbows, service entrance, elbows, and all these are good examples of conduit bodies. Any ease of installation of the conductors, number 6 or smaller. Number 6 or smaller. I think I'm going to give you a break in a second here, and then we still have, okay, damp and wet location. Let me cover these before we go into the calculation, yes, because I'm going to look at, we all guys have required the use of vapor tight boxes on outside wall building. Very, very interesting. And I'm going to ask you guys, how, let me highlight this one and ask how, okay, you have local building codes, which a lot of them approve. Look at this and tell me if it's enforced in your area. The building code may require the use of vapor tight boxes on outside walls and ceiling. That's their proof boxes. Do you guys use them? A lot of enforce them in an outside wall. So yeah, weatherproof boxes. I think it was a picture of it, and on the slide shows you. Any outside boxes, outside walls and ceiling. basically tight verti. And here, guys, there will be no so installed and sealed. Tight boxes do not allow the air to move inside the house to the insulation cavity, so saving energy. And as a result of this, no moisture will be accumulating, and then no mold will be growing right into basement. So two in one stone. Number one, you become a tree high your friend Chad, because now you're saving in the heat cooling business. The cool heat is not transferring between your house and outside. That's the reason for using it. And the second thing, as the moisture gets from the outside in and accumulates inside the cavity of the sheetrock walls, it will of course allow the mold to grow, and that has another health hazard issue. So that's building code, and a lot of inspector guys enforce it, which a paper tight boxes only the outside walls and ceilings of a residential house. Anything else? Any questions? Conductors. With conductors, guys, I'm going to give you a break right here. So let's see, it's 6. Let's reconvene at 7. It's 7:02. How about that? I'll give you close to 6 minutes, guys. All right, let's get back at 7:02, and we'll conductors. Okay, please. Oh, thank you. Everyone is back. You probably sleepy tonight. My son was sick last night, so I had to stay over all the time. So everybody's here. Now, number of conductors in a box. How many conductors we can use in a box? There are two tables. If you have not using these tables, very, very important. You can't pass a German exam without knowing these two tables, which is 314.16a and 314.16b, and they have not changed in 2011. So here's the size of the box and how they can put in a box, and is this box can fit all conductors in it? All these answers for all these questions, guys, you can find it from these two very important tables, 16 and 16b. Now, conduit bodies, they have another article, guys, which is C. They look about them. It talks about them. And I'm going to go. Let me see here. Standard boxes table 316 boxes. Let me just a flash before we do that. Let me just go flash my share my desktop. Let's go desktop and just look at this table. Make sure we know. Here's my table. Grab my code book. And if you guys give me 1 second here, here's my conduit. Okay, whole boxes. Let me move this one away. So move the way, guys, to this table. Table number 316A. Very important. This is only for metallic cables. Before I go to this table, guys, I want to bring to your attention a few things. Number of conductors, volume, stand, others. Okay, the standard boxes 310 or 16. If you have other boxes, you can use include. This is a lot of people can forget that one. So boxes, no problem. You're going to go always to the one that I'm going to be showing you. How about other boxes? Other boxes with smaller than this, other than described in this article, or non-metallic boxes. This is where they catch you. The non-metallic boxes shall be durably and legibly marked by the manufacturer with volume box. If boxes in this table have larger than their volume must be required by this section. Will be permitted to have a volume marked as required by this section. But the most important thing, if I'm going to mention, is non-metallic boxes have to be the manufacturer with how much they fit. That one, how they can fit conductors. So very important. The metallic boxes right in here. All right, on to the table. If you're use this table, it's very interesting. I assume that you have it, but I'm gonna explain it as if you not use it. Let's say, guys, I'm gonna use a square box. You have to decide what type of box. I want to use a square box, the shallowest square box, which is 1 inch and a quarter. Okay, and then of course square box guy can give you a volume of 18. How we read it? 18 square inches, cubic inches. Now I can, if I'm using this box as a box, just use it as a J box, and I decided single-handedly, Chad Kirby, I'm in a commercial, so I used all number 12. I can bring number 8 conductors to this box as J box. Okay, easy. So very good, Chad. I have my conduits coming in here, other conduits coming in here, and the third conduit coming over here, and this on, and I'm going to splice these conductors. I'm going to go grab my conductors, and I'm going to minimize it to a pencil. Okay, so here's conductor number 1, conductor number 2, conductor number 3. How many do we say? Here's a conductor. a factor from here, a fourth from here. How many we have? 6, and then bring 7 and 8. Done. And then I start splicing these conductors wherever they need to go. So this now has 8 conductors. This has 8 conductors coming and in it, terminated in it. I can't add more than conductors. Now, what happens if I need more? I need to pull more conductors. Then you have to go to a deeper box. Here's a deeper box. This can be all the way up to 30.3. I can put 13 conductors. That's my friends. Let me grab you guys. The presenters. Let me grab letter and grab it right here to my other screen. That's why it's always a smart idea. Smart idea when you do commercial to put a deeper box. Don't go for an inch and a quarter. Go for at least 4 by 2.5. You know, to give you ample amount of time. So here's another 13 conductors I can bring to this J box. Any question is about the use of these J boxes? Just conductors coming and spliced in the ceiling. Any question? So a deeper box. If you're doing commercial, it allows you to do a lot of stuff in it. Now, decided to use device box as a box. It's just I want to use this device box, the deeper, very deep device box, 3 by 2 by 3.5, K18, and I want to just bring conductors and splice them, no devices, no devices, and I'm saying all the conductors are the same and they were all number 14. So I bring 9 conductors, number 14, inside this box, splice them and push them back and put a cover on it. Okay. So basically, here's your devices, masonry boxes, the FD and FD, these conduit bodies and so forth. The round boxes at the top. I will bring to your attention device boxes. So this is your square box. Wide square boxes, device boxes, octagonal boxes at the top, and masonry boxes, and the fittings that comes with it. Any question about using this table? Very important. So you know how to use this table. And moving into, so this is table 1, guys. You don't go to town without knowing how to use it. We're going to table number 2, which also you can't go to town without using it. Yeah? Table number 2, this is what I call it the fuzzy math, personally being an engineer. They allocate a cubic inch for every type of conductor up to 6. For every conductor up to 6. From all to 18. And someone might say, Chad, what the heck with the 18? Well, what if you're using the box for control, right? You can use 18 and 16 for control. For the most guys, we're using these for the power, but you could be using control. Okay, using number 6, bringing it box, you have 5 cubic inch for number 6. Using number 12, you have to allow 2.5. 2 and 2, I mean 2 and 2.2 and 2.5, and you can read how they correspond to each other. So these are the most important. With 14 to 6, from 4 to 6 it goes 2, 2.25, 2.5, 3, and 5. Okay, so piece of cake, Chad. If you have if a box, I have and I have different conductors coming to this J box, right? I have different conductors coming to this J box. These are conductors. All are coming to this J box, right? And as far as my J box, let's say all these conductors here, how many conductors? 1, 2, 3, 4, 1, 2, 3, 4, and 5 conductors. 4, 5, and 3. Let's say just for the heck of it, these all were number 14, these all were number 12, and these all were number 10, right? Piece of chat to find for the box that fits all these. All of them are coming, guys, and terminated in this box. No devices. So let's start with the 12 here. Now let's start with the 14. For number 14, guys, how many of them do I have? I have 4. And multiply the 4 by the allowance for 4, which is 2. Let's go 12. And 12, how many 12 do I have? I have 5, right? Multiplied by 2.25. 2.5 cubic inches. Okay? Picture. How about number 10? For number 10, guys, I have 3 of them. And my allowance for number 10, which is 2.5. 2.5. Okay, calculator like your friend Chad, you start your math. 4 times 2 plus 5 times 2.25 plus 3 times 2.5 equal 25. I added them all up, multiplied them. I came up, guys, with a 25.25. Okay? 5.25. Remember that one? Any questions about this before I go size that square box? Any question? Any question how I calculated them? I just add these conductors are terminated in a box, and I'm using it as a gearbox, a square box, but I know what size I need. Okay, some of you would say, Chad, how about future expansion? That's where you become smart, guys, and start future expansion. Please get rid of my Alright, so I know it's 25 point. I want you guys to remember that that one right here, 25.25, right? That's easy to remember. Get up. Now let's go to the table. The conductors. It's a square box. I single-handedly checked decided to use square box. Okay. So here my square box is. Where's my mark highlighter? Of my square box is. Let's start with square box, guys. I need 25.25. Well, that gives me 18, no. 21, no. My option number 1 is 30. That might not be a bad option. Let's go to a deeper square box. If I go for a wider square box, this one, I can get away with a 25 right away, guys. So that might be the best option for me to go wider square box, not a 4. It's a 4 and what is it? A 4 and I should read it from here easier. A 4 and 2.8. A 4.11, almost 5. 4.11, 16. So option then, my best option for if it's a square box, based on this way actually to use this box right in here. Now the other thing that I would ask you, Joe, I said, what's your future expansion? What happens to your future expansion, right? What if you want to have future expansion? Right? When you have let me just erase that one. The future expansion. If you want a future expansion, guys, what I would do is I would use for the 30, which would be that box, because it will be more cubic inches to fill in the future. Because Joel and Matthew, my friends, when you guys are doing it for your exam, you do write based on the code. You don't picture expansion and all this good stuff. Anything guys how to use these two tables. How to use these tables. For the next one, Chad, make sure they're not put you to sleep yet. No. Okay. Last thing I want to show you guys from these tables before we use them in a couple of examples here. Okay, a couple of things, guys, about conduit fail, clamp fail, and support fittings and devices and all this good stuff. You have to pay attention to equipment guard conductors and these guys. Let me go back to my. Okay, so moving on. So these tables, we have to use them. Now it becomes what counts and what cannot, what doesn't count. Conductor fail, what counts, guys? Every conductor counts as one. If you have a conductor that loop the conductor more than 12 inches inside the box, more than 12 inches inside the box, more than 12 inches, the conductor count as 2. So every conductor counts as 1. All clamps count as 1. Both fittings count as 1 each. Equipped on grounding conductor all count as 1. You have devices. Yeah, the equipped on grounding conductor counts as 1. Devices. Devices, guys, devices count as 2 based on the conductor landing on them. 2 based on the conductor landing on them. Let's go and look at this example. This is a good example. Box, and I see how many conductors count in this application. How many conductors count in this application? All right, you guys, we have a volume, existing conduits, and let's see what's the existing volume in that. Let's start counting, guys. I'll count the black. Look at this. I have 1 conductor coming from here, another conductor. So it is 2, right? Pigtails don't count. So here's the first coming in, the 2. Then I have the neutral. I have 1 neutral coming here and 1 going out. There's another 2. So hot plus 2 neutral. Okay. And since I'm pulling an isolated ground, since an isolated ground, this counts as 1. Here's 1. Here's 1 out. Plus 2 for isolated ground. Okay. All pigtails count as 0. So this piece here, and piece coming to here, and piece going to here, and all pigtails and another piece, picking the neutral and the ground count, all these count as 0. So device, this really has 6 conductors. Okay? So these guys, all these conductors were numbered for the cover. Let's say it was number 12. Okay, number 12, I have 6 conductors, and if you go to number 12, the multiplier is 2.25. 2.25. Okay, how many devices? Devices, I have 2 devices, right? 2 receptacles, multiplied by 2 each, because 2 allowances for each, based on the largest conductor ending on them, which is 2.25. You guys do your math on this example. It will be 6 times 2.25 plus 2 times 2 times 2.25 equal 22. 22.5 cubic inch. 22.5 cubic inches. That's how much cubic inches all these are occupying, the conductors and the devices. Let me myself, guys, if you are, the devices always count as 2 based on the conductor landing on them. Any pigtails count as 0. Why not count as 0? Devices 2 based on the conductor landing on them. Any question guys about this? Straightforward. A number of conductors terminate. Any conductor that originates outside the box and terminates inside the box count as 1. But it has to start outside the box. That's basically calculation, right? And I'm going to go this one and tell you that this box, guys, let me just say this box has volume of 30.3. 30.3, that's a 4 by 1 8. This was a 4 square box by 2 and 1 8. Okay. All right, Chad. All right. We're gonna see. Here's how much I'm occupied here. If I ask you how many extra conductors can I pull in a box? How many extra conductors I can pull and terminate in this box? So, friend, then you go and you tell me, Chad, no problem. Here's what I would do it. I'm going to go to calculate the existing box, not with yellow though. Yellow's not going to get me anywhere. So my box is 30.3. have a ring, mud ring around it, which is 3.6. So add these two together, guys. That's easy to do. That will get me at 33.9 cubic inches. Okay. So the question, my friend Brenna, is how many extra conductors can I add to this box, right? Well, this is how much the box can handle altogether. Subtract the already occupied used space, which is 22. So you take 33.9, subtract 22.5 from it. You get 11.4 cubic inches. This is the spare that I can populate in the future. The spare can populate in the future. Okay, how to populate it? What do you want to pull? I decided, Chad Kerry, I'm going to be pulling conductors and terminating them. Conductors you can pull and terminate. I'm going to be pulling the conductors number 12. So take this number and divide it by the allowance for number 12, which is 2.25. 2.25. If I 2.25 divided by 2.25, that will give us 5 conductors. This means these are, Matthew, my friend, these are the number of conductors, extra conductors that I can pull through. Pull it. So conductor 1, 2, 3, 4, and then 1 here, 5. Coming and terminated inside this box. Actually, guys, any questions? A question like this would be definitely in your journeyman exam. Guarantee you. I check, guys, for the journeyman, guys. And have a box. There's a volume of a box and a bunch of pairs and devices, and tell you how many extra conductors you can pull through with a loop or terminate in the box. In this, how many extra conductors I can terminate in the box? It's 5. Anybody has any questions? Question that one. So let's look at how many of you. I want you guys to look at this and tell me how many conductors. Let's look at this one. Well, both of them are identical in this case. Count as one ground conductor, and so ground conductor. I want to emphasize, if you have an isolated ground, count as 1. How many conductors do I have in this spot? Here is my conductor. How many? And receptacles. You guys have this one with me? Can you tell how many conductors do you have that count in this box? Conductors, and then how many receptacles and how much the receptacle will count. How many conductors? There is the green FI is an isolated ground. Isolated ground. I'm going to check how many conductors. Anything pigtailed? Anything pigtailed, guys? Any pigtails does not count. Isolated ground will count. Can you guys chat it with me? I don't see your chat, guys. What's going on? Let's count for this box. Okay. Just not a receptacle yet. Let me just make it easy for you. For a receptacle, I have one of them, and then as 2 conductors. So that's 2 for the receptacles. That's easy. Conductors that count. I want all of you guys. Okay. All right. So count them. I have 1 coming from outside terminating. Another 1 coming from outside. This is 2. The third one coming is 3, right? And I hot. This is 4. I also have my isolated ground. This is 5. I have 5 conductors. For those who counted them as 7, then if you add all of these, it becomes equivalent to a conductors. Equivalent to a 7 conductors. I will count as 1. This ground will count as 1. If you have internal clamps, will count as 1. So that's very important. Before we leave this topic, guys, a couple of things I want to mention. Equipped grounding conductor. Equipped grounding conductor. Let's go in. Very good point. Equipped grounding conductor. Let's one more time. I think you are absolutely right. Let's count them one more time, guys. Here's one conductor, the neutral. 1, 2, 3. 3 conductors for the neutral, right? And here's one for the hot. It's 4. This is ground 5, and the ground 6. So there should be. You're absolutely right. There should be 6. We forgot that you count the ground twice. One for isolated ground and one for the ground. You're absolutely right. I forgot that an isolated ground here. So that there's ground guys coming in, 2 grounding conductor. If it's only grounded through conduit, if there's 2 grounding conductors coming, you count one of them isolated, of course, and you count 1. So that will be 6 conductor box, plus 2 for the device. That will get you an 8, and a conductor box. Any questions about that? Thank you for correcting me. Grounding conductor will count. That boy here will count. There's 2 of them. They count as 1. One thing I wanted to mention, guys, if you have a box, and in this box, this is always an exam, and you brought, here's my conduit coming in here, coming out here. Yes, I want you to write it down. So if you put a conductor right in here, you loop the conductor, loop it, and get it out. Loop, the whole loop here is more than, if it's more than 12, then it counts, this conductor here counts as 2. They count as 2. If you put a conductor right here and you just moved it right through, moving, this one, very important. If it's more 12, it counts as 2, then 12. 12 less, it counts as 1. Anything going through, it counts as 1. Any ideas about this? This is always a tricky one. If they're looped. And we got that one. Conductors, devices, support clamps, conductors. This is loop or core loop. Unbroken conductor, not less than 2 length, blah blah blah. Not less. So required for 3 conductor, blah blah, shall be counted as twice, not less. So any more than 12 or more will count, right? Less than, not less than twice. So if it's less than twice, it doesn't count. It doesn't count. So it has to be more, like we said, than 12. If it's more than 12, it counts. Any question, guys, about this? Anything about this? This is kind of a tricky one. Tricky one, guys. If support fittings, if you have if it can be, and you bring in conductors to a light from a canopy, and the 4 fixture smaller than number 14 will not count. If you have not more than, So if you have a fixture here, canopy, and you have conductors, or just place your fixture right in here, and you type the fixture is fixture, light or fan or whatever, and all these conductors coming in, guys, originated from the fixtures, 3 up to 4, and all conductors are fixture wire number 10 or less. Do not count. You put more than number 14, start all of them start counting. So if you have 14 or less, they don't drop them. Closer to canopies and so forth. So basically, it in terms of guys, any about box fill calculation. Any question about box fill calculation? There's a couple of examples that you guys are going to have on the test. So all moving to other topics, guys. Next time we'll get back to this one too. And be closed in a box. We all know that because you don't want to burn fire and you don't want animals to walk right into your boxes and all this good stuff. Walls or ceilings. Does this sound familiar, you guys? If you have boxes flush mounted in the walls of non-combustible material, such as concrete, must be set back and in a quarter of the finished floor. So a quarter if it's non-combustible. If it's combustible, they have to flush it, right? Remember that flush combustible material such as wood must be flush or extend beyond the surface. But if it's non-combustible, you can sit back up to a quarter. If the material is non-combustible, if it's combustible, then you have to be flush it or it has to extend. So in the exam, the review guys that we were doing, rear of drywall, guys, wall, plasterboard surfaces that are broken. And I'm not sure how many of you guys have broken some of these when you're remodeling. Ink around the flush type covers or base plate shall be repaired within the 1/8 of an inch. So in your device here, within here's the box. Go there and repair this stuff with, round box within 1/8 of an inch. They don't want you to go to the fraction of an inch. 1 inch. So that's repairing. Surfaces extending shall be made mounting and securing an extension ring or flush cover. I don't know, guys, how many of you guys have seen a box in the wall, and you extend the box. There's a issue for the box. So you have the box here. Of course, this is the wall here. You extend the box, and then from here, I attach a conduit. Oops, this goes different color. I conduit, and I moved all the way up here and all the way up here. And this is, by the way, this is the wall. This is the wall here. Thing is inside the wall, all the way up to here. That's inside the wall. Okay, so if you have to extend it, guys, you have to maintain the integrity of the grounding system by attaching it properly and bonding it. How many have installed an extension of a box? Extension of a box for whatever reason? You go system to another, from wire in the wall into a conduit outside. Box is set back too deep, so you put an extension on it, so it brings it back. In finished surfaces, opening for boxes in existing walls or ceilings should be cut where members will not interfere with the box placement and where can be finished into the Guys, you're not going to cut right where the 2x4 is located and then chuck the 2x4. Boxes. If you have go down, they use them a lot, guys, in manufacturing. And here's my receptacle at the end. This is my receptacle. Flexible cord. It's not a wiring system. It's a cord dropped from pendant. A pendant up for an outlet may be supported by the cord, no problem. If it's attached to the box ceiling and the pendant box by a strain relief. So what they do is they put a strain relief on these here and put strain relief on these connectors that are attached to the box by means of a threaded hub. I have installed this cord, the receptacle at the end of the cord in the manufacturing, supported from the top of a way or something. Very cute. So if you're right in here in the middle of nowhere, you can plug in. So that connector attached to by the means of a threaded hub. Depth of boxes and outlets, guys. What I'm going to reach shall have sufficient depth to allow equipment installed within them to be mounted properly and with sufficient clearance to prevent damage to the conductor within the box. In 2008, they changed it, guys. How many times, guys, I installed a GFCI in an old device box. And I'm not going to tell you how many times you have to push it with the back of your hammer, with the hand of your hammer, push everything in the connectors, and you busted the GFCI because that GFCI was so fast and fluffy, and it can't fit in that tiny little box. How many of you guys encountered that? A GFCI in old homes where it can't fit in the box, especially the rimmer. So before that, in 2008, my friends, went and changed that one in 2000 and still 2009. They get into minimum depth, which is 314.24. 314.24 right in here. This article gives you the minimum depth all the way up to here. So if you're really interesting, outlet boxes without enclosed devices or utilization cord, but no box shall have an internal depth less than a half an inch. No minimum box are going to have half an inch. Without a device, outdoor device box with enclosed devices, if you have to put a device on it has to be at least almost an inch deep. Utilization equipment, if you have to put utilization equipment in it, guys, look at that. Equipment, if you're tying large equipment, boxes that enclose utilization equipment that project more than an inch and what is it from there? So this is number 1, inch and 7/8 of an inch from the mounting plane of the box shall have a depth that is not less than the depth of the equipment plus a quarter. So they want you to get even an extra quarter. Conductor larger than number 4. If you have conductor larger than number 4, equivalent of a conductor larger than number 4 shall be identified for the use. Conductors 8, 6, and 4 boxes that enclose conductor 8, 6, and 4. The depth should not be smaller than 2 and 1/16. So conductors enclosed at 12 and 10. So it's one internal depth that is not less than an inch and 3/16. Equipment project rearwards from the mounting plane 1 inch. The box shall have a depth less than the equipment plus a quarter. So they make it clear, guys, they want you to use a deeper box. Conductor number 14 and smaller should have a depth that is not smaller than 5/16. So hopefully by this, it will guarantee that you're not going to be able. There is no need for you to pancake all these wire nuts and wires so you can push your GFCI or dimmer right through a box that doesn't fit. Right through a box that doesn't fit. So I thought really interesting. They did it in 2008. Basically, the depth of the box depending on the conductor that's entered. Any question, guys, about the depth of the box? Any question about the depth of the box? Depth of no. Okay, we talked, guys, about present canopies. Each box should have a cover, a flat. The boxes have to be covers, flat, a faceplate, lamp holder, luminaire, and for part, so you can't just have the box uncovered. Fixture support. Listed outlet boxes are marked. If the box is going to be supporting the fixture, it will be listed as support of a fixture, and you cannot support up to and including 50 pounds. Matthew, my friend, if you have a fixture that's bigger than 50 pounds, then you hire your structural engineer, and you have to provide trusses for it, and you support it independently, independent of the box. So 50 boxes used as aluminum or lamp holders shall be designed for the purpose and shall be marked to indicate the maximum weight of the fixture that's permitted to be supported by the box other than 50 pounds. At every outlet used exclusively for the box shall be designed or installed so the aluminum may be attached to it. So if you have a box that you need to attach aluminum, you have to have linear and can support up to 50 pounds. Don't get confused between this one and 35 for fans, guys. 35, the fan box has to support 35. If it's in 35, it has to be labeled, and you cannot support any fan more than 70 pounds. At 70, you have to hire your structural engineer after that. So basically, in terms of box support, before we move into the pull and junction boxes. The pull and junction boxes, any questions? We talked, guys, about the pull boxes, especially pull boxes. Box to qualify as a pull box, here's the rule. It has a number 4 charger. So for any box to qualify as a pull box, it has to have at least one conductor that's equal or the number 4. So if a conductor that's equal or the number 4, then my box qualifies as a pull box, and remove the calculation that J boxes no longer apply to it. So J box could be used as a pull box or J box. For example, I have a box here and brought multiple conductors here. These are 3 conductors, number 10, for example. And here, multiple conductors. All these conductors are number 4. And let's put a conduit around them just to make it legit. Here's my conduit around them. Is wood, and my conduit on these. My conduit. Now, like this is not a box. This is a pull box. Why it's a pull box shed? Because it has at least one conductor more than number 4 or more. Number 4 or more. Minimum sizes, raceways contain. We'll talk about the minimum size conductor for pull boxes, the covers. All junction boxes have to have a cover, and barrier where permanent barriers are installed in boxes. Each section shall be considered as a separate box. Where could be box. A couple of things on barriers, guys. might be in a situation where you have to separate the boxes. I have a low voltage in this side and a high voltage in this side. It's okay, no problem. You have a permanent barrier between them. And bring your conductors and conduits from both sides to go take both systems. But you have, and each one of them will be considered in a cover, but each one of them will be considered a different box. What a barrier is. You need a cover for everything. And sizes, I'm going to be passing on it in a second here. Any question, guys? Cover and permanent barrier. Have permanent barrier for different voltages, different systems. And okay. Wheel boxes, JC. It's a box that has at least number 14 conductor or larger. With full boxes, guys, we size them. There are a couple of rules you have to apply to the full box. And in page 173. This will be before that one, guys. This one, if you pass your journeyman exam, must be to your heart. Unreal. Full boxes are classified as a straight pole, as you can see. This one that you're looking at right here is a straight pole, right? Straight pole. Why, guys? Because I'm pulling the conductors from one wall opposite the other wall. That's straight pole. You're entering from one wall and exiting immediately from the wall opposite to where you entered. Okay? Let's make a straight pole. If I bring a conduit from the top here, enter from the bottom here, okay, you should that. This all will be a straight pole, right? Well, and conductor is coming right through it. Well, that's a straight pole. Alright? Okay, now, when you straight pole, guys, you can find the distance from where the conduits enter to where the conduits leave. With it, the largest conduit engaged is 2 to 2, 18. So the distance width of the box is 16. Any questions about how they came up with 16? Why 8? Because the code is straight pole. To start straight pole, you take the largest conduit engaged in a straight pole, multiply it by 8, and that will be the width of box of this box. Okay, Steve. Now let's see if we can find the height of this box, right? This one. To find this box, let me tell you that this conduit is, I decided, Chad Kennedy, to use a 5-incher rigid. Right? Inch rigid. Cut to this box. Okay. And tell me what the height of this box if I'm bringing, and this one here was a 4-inch rigid. And ask me, Joe, why I entered with 5 and left with 4. I like it. Okay, so you guys tell me, share with me, and tell me what the height of this box. It's to give you a hint, it's a straight pole, and the rule of a straight pole right in front of you. Based on this, what would be the height? A couple more. I need a couple more. What's the height? Look at that. I'm coming from one wall, exiting opposite wall. That's called a straight pole. That in 2.28, I mean in 2.14.28, if you're straight pole, 8 times the largest conduit engaged in the straight pole. So options, guys, are 8 times the largest conduit coming from the top or leaving from the bottom. Which one is the largest? The top. So that would be 8 in this case. Thank you. I got from most of you. 8 from the code times the largest conduit, not the 4. That will give me 40. The depth of or the height of this box is 4 inches. Any question yet? Any questions? Straightforward, right? No gimmicks, nothing. Any questions? One more example, and then this is called the straight pole. Here we have another conduit coming from here. And this conduit was this conduit was 4 inch, and this conduit was 3 inch. Depth of this box, width of this box. One, the conductors are coming from here, leaving from the other. Well, based on this, guys, what would be the width of this box? All right. All participants here, you're supposed to send it to chat only, guys. All right. So you take 8 times the largest conduit engaged in a straight pole, or 1, 2, 2 incher, yep, another 2 incher, yep, a 3, and 4. Which one is the largest? Obviously the 4. So 8 times 4, and if I did my math right, it's going to be 32 inches. 32 inches. Now, if I ask you guys what is the height of this box, as I cannot find the height of this box based on this information. You can guess probably. If I would guess it, I would say, okay, this just by 2 inches, right? I need the space for 2 inch conduit, plus I need space for 3 inch conduit, the worst scenario. That will get me 4 inch, right? Plus, well, lock nuts, and enclosures and so forth. So that's basically 2 inch, 4 inches you need. And how far you will go from the edge? I would say probably you might need from both sides, from this side here and from this side here, you might need half an inch at least, an inch plus half inch plus another inch between it. I did not code, guys, by any means. What I'm doing now, it's not code. So that'll be 2, 4, 6, and 7.5. 7.5. Approximately the height would be. Here would never new test because it's judgment. Here's like making a new test. I put a conduit here, bring it from the bottom. Now we're playing it's with Paul. Okay. What any question is? One more. Any questions? No questions. Okay, let me move into that. So that's basically a straight pole. Guys, give you a 5 minutes break and myself back. What's that? 5, 6, let's say 8 like we did last time. 8:02. 8:02. Okay, now quick break and then we'll come back. We'll do the U pole. Can you check him, please? Everybody's. Thank you, man. Let's head now and talk the angle pole. This is what you guys are looking at is called angle pole. I want to keep the same thing. I want to keep emphasizing this is only if the conductors are number 4 larger. Like these walls. Okay, so pole you can size both dimensions. What I want you guys to look at. This, first of all, apply the rule at this wall. So applying it right at this wall. So that's coming from this wall, and where are they going? Going to the left. Coming from the top, going to the left. Coming from the top, going to the left. Right? Looking at it from the top, they'll give me this dimension. The opposite to where the conduits enter. If the wall, they'll give you the dimension opposite to where the conduit enters. So that dimension, which is the axis. Let's see. So the code says it's 6 times the largest conduit on that wall, which is the one that you guys just got here. 3, the largest conduit, plus other conduits sharing the same wall, which is 2. That would be 20. Yes, any question how I came up with a Y, the height of the box of 20? Of the rule on the top, and conductors are going to the left. Okay, top to left. One color. Now I'm looking at this wall right here, from right in here, right? And conductors are going to come and they go to the other way. So see, I'm looking at this wall. This wall. So 6 times the largest conduit, still 3, plus all the other conduits that enter, and you another 20. Here's how we came up with the dimension of 20. Any questions for Chad? Okay. Let's make things more interesting. Let's make things more interesting. I need to add one more conduit here. Make this conduit come from the top and leave from this side. You guys have that? These are coming here and leaving this way. How I change the calculation? This calculation, the same thing on this wall. I will this direction. All right. This count, by the way, was 5 inch. I like 5 inches. 5 inch. 5 inch. I am sure. It is top to bottom. It says 6 times the largest conduit engaged in a U-pole. The largest conduit engaged in a U-pole. Which one is the largest? I have. It could be engaged in a U-pole, by the way. 2, 3, and 5. That's a lot of conduits in the same wall. At 3 and 30, 33, 35. That will give me 35 inches. And here's what this 35 inches. 30 inches tall. Okay? Now we go apply the rule to find the width. I will apply the rule in this wall. Give me that distance from here to here. Yeah. Apply the rule, so it says 6 times the largest conduit entering this wall, which is 3, plus 2, equals 20. This is still 20. apply the wall, guys, at this wall, right? If it's 6 times, right, it's a U-pole, 6 times conduit 5, is 30. See the you get the difference. 6, 5 equals 30. So which number do you guys going to think we're going to pick? So this conduit it'd be 30 by 5. Question about this, see how first application gave us 20, but we went to the other wall here, and then because this gives us a U-pole, right? Going up, and so this is going up, giving us a U-pole. And so my box, as a matter of fact, now is 30 by 35, or 5 by 30, 30 by 30. Any question, guys, about this? See, adding that conduit change the whole dimension of this box. So that's basically what it's that one. All right. The other thing is also the code says the distance between conduits containing conductors, and drill the hole here and here. You have to maintain this distance. For this one is 6 times the largest, which is 2, so that will give 12 inches here. So these two holes, the edge of 2 holes can be closer than 12 inches. The same thing, 6 times the largest conduit gauge, which is 3, is 18. This distance here cannot be more than 18 inches. Only conduits that contain the same conductor, guys. Minimum distance between them, 6 times the largest conduit. And any question about the U-pole, angle pole? Any question about the angle pole? Other than you be careful when you apply the rule. Alright, we have a straight pole, guys. We know straight pole. Angle pole. This is my angle. And we go to the U. What do you think this looks like a U? This is like a U-pole, right? Makes a lot of sense, huh? If you're the U-pole, guys, look how easy that is. You're going to apply the rules at this wall. So look at from this way, 6, so that will get you the opposite junction to the opposite wall to where you entered. So code says always multiply by 6 times the largest conduit engaged to every other conduit sharing the same wall 2. That'll get you 14. Any questions how they came up with 14 inches? And all right, the talking, guys, the distance between the conduits right in here, because they're in the same conductors, the two conduits cannot see. It has to be 6 times 2, 12. So earlier holes, make sure that these holes are 12 inches apart if they're containing the same, if the conduits are to house the same conductors that number 4 or larger. My love, gentlemen and ladies, and how do you size this distance? My first question is, does the information that you have right now allow you to size the code? Do you have information to size it based on the code? How about X, no, green check, yes? How about screen check? Yes. Do I have information to find the width? No, I have information to find the width. Based on the code. I predict the width though. I can predict the width. Let me tell you how I can predict it. Well, I need a 2 inch for the first conduit. Plus, the conduits have to be 12-inch apart, so I have to put the 12-inch apart because I code. The second conduit space. Oh, now here is judgment. Do you allow half an inch here, an inch here? They're 12-inch apart, so it might give another inch. Again, that's called judgment here. So the 12 plus 4, 14, 115. I would minimum that 15. Is this code calculation? No. This is judgment. Any is any that's basically what the U-pull is. The U-pull will not be with U-pull. You will not. The only thing the U-pull will give you is opposite and between the two conduits. That's all you get out of it. All with the conduits enter that distance, and then the distance between the two conduits. Okay, now that you guys know, before we move, there's one that always comes in exam, guys. The 3D of a box. Imagine that's my 3D of a box. I have a conduit coming from the back. This door, there's a door, as a matter of fact. This is my door. So I'm coming from the back, and the conductor that I'm bringing from the back, right here, this conductor from the back, this is a 500 kcm. 500 kcm. How am I bringing here? 2, and I'm bringing 3. And I just bring another 1, 4. I'm bringing 4 conductors from the back of the panel into the back, right? And the door opposite to it is the door. Conductors to a box, and opposite to that box is the door. That calls you guys as an exception to go to table 3.10.312.6a. They'll require per terminal. And sure, and also if you guys read through the exception, it says 1. Maybe you go to 1 wire. Make here 1 wire per terminal. So if you go to this table, which is a couple of pages before, and you get the depth of this box based on 1 wire terminal, which I looked at this table, guys, before. Okay, so let me share my desktop since I already have it on. Desktop monitor. So if you get this, the 500, right? Okay, where am I here? Let's go to a highlighter. So if you look at if you look at 1 terminal, can you guys see 1 terminal? terminal because it says one terminal. And 500, here's my 500. If you're crossing it, the box is number 6. From this all the time. Okay, so I'm going to go away from sharing my desktop. Take you back. Then depth of this box from here to here cannot less than 6 inches. And that's on a journeyman exam. Repeat. And guys, so I can see that you guys moving. Any question one more time? Thought that's a special case. Which is the depth of a box. It comes from the back to the front, where there is a door. It doesn't have to be back to front, guys. Joe, it could be side to side, as long as the conduit enters from one side. The opposite side is a door or a removable cover. A door removable cover. Anything you can remove. That is, you can pull the conductor easy if you can remove, if you can get your hands in there, and you can get your hands if that side is removable. Exception that state of Minnesota likes to put in your journeyman exam. Time. Basically, guys, it's in terms of this. If we have time, we'll do some more calculate, see how it goes. Okay, boxes to be accessible. Boxes, conduit bodies, handhole enclosure must be installed so wiring is accessible. You go cover sheetrock over a J box or a pole box or a device box because the have to be accessible. And probably have seen, guys, a lot of troubleshooting. I don't know how many of you guys have been in a place where you troubleshoot, you idea what's going on, to discover that there's a J box or a box that has been sheetrocked over. So when you think to look at all these terminations, what's going on, and there's no way that you can troubleshoot a circuit if you don't know where the J boxes are located. So these have to be accessible. More instruction specification for the boxes, guys. This is people who manufacture them. Corrosion resistant, especially in a corrosive environment. Fixable metal, suitable for the application for the most part. So 40. Thickness, it says sheet steel boxes not over 100 cubic inches shall be made from a steel not less than 0.0625 thickness. Go over, and so that's the thickness. Number C, boxes over more than 100 cubic inches should be constructed so as to be ample strength, rigidity. If of sheet steel, metal thickness shall not be less than 0.053. And mainly for the big boys who make these. These metallic boxes have to have some type of a means of grounding it. A spot where you can ground the attach and bond the box to the equipment grounding to the. So basically, in terms of grounding and a couple of things, covers 41. It is shall be of the same material as the box of the conduit body, or shall be with insulating material at least this amount of depth. So, it says metallic boxes shall be of the same material as the box or conduit bodies with which they are used, or shall be lined with firmly attached insulating material that is not less than 1/36 inch thick, or they shall be listed for the purpose. So, for the purpose, and like this insulation with thickness. So it's the same material with the boxes: metallic, non-metallic, non-metallic. Bushings. Number of outlet boxes having holes through which flexible pendant may pass shall be provided with a bushing or have a smooth, well-rounded surfaces. Push. I think I have. So that's insulation bushings, guys. That's 1.2. Yeah, about bushings, minimum wire surface. Okay. Of things, guys, about okay, covers or outlet boxes, which flexible cords. Okay, so that's 20. Okay, let me just see if that's method that we're going by 300 for okay. Both the bushings or adapters required to protect the conductors from. Oh, so that's basically the adapters and the bushings that we need. 315.24. A box, I really, I wish I can throw it here in front of you. It's really nice about insulating bushings to protect the conductors. And is rigid conduit or intermediate metallic conduit. This is just the threaded. You need the insulating bushings for any size. Any size, okay? Now you go and grab yourself the same rigid, guys, but now with a piece that's non, so it's like a fitting, EMT fitting. Then you only need it with number larger, number 4 or larger. Okay. If also using EMT, this is the rigid. You're using EMT. You know how fittings for EMT. These are sets of screws. You need insulating if it's only 4 or larger. Number 4. Rigid EMT. This is E, electrical metallic tubing. The same as apply for PVC. Long story short, if you have a conduit, any conduit, and the conduit, guys, containing conductors number 4 or larger, you need an insulating bushing to protect the conductors. Number larger. All rigid and intermediate thread ones with the thread fittings, you need for everything, for every type of conductor. Question guys about this? So just to summarize, as I said, number 4 or larger for all the conduits, 4 or larger for all conduits, rigid, EMT, you name it. Rigid with a threaded couplings, meaning you don't have the set of screw with rigid. Remember, with rigid, guys, you can have lock nuts. You put the whole threaded, and you do nuts from both sides. That's what you're using. Then you need it for all sizes. If you're using with the rigid and non-lock nuts, we're just using connectors, and use the rigid unthreaded connectors with rigid and intermediate. You can't. Then you apply the rule of number 4. So the key point, Eric, to remember is number 4 or larger, you need insulating bushings. Now, then, is it wrong to put insulating bushings for everything? No. No. So that's basically bushings and support and so forth. Non-mix boxes for support must be made outside of the box. Provision for support must be made outside the box for non-metallic. All boxes, conduits, boxes, blaster shall be durably marked with the manufacturer name and thread number. And that's been it in terms of conduit, guys, before we move into part 3, which talks about high voltage. Any questions, guys, before we move into high voltage full boxes? summarize, guys, especially for full boxes, we see straight pole is 8 times the largest conduit. Angle, 6 times largest conduit plus all the other conduits sharing the same wall. U, same thing, to where the conduits enter, distance from where conduits enter wall to the opposite wall is 6 times the largest conduit engaged in the U pole plus the conduits sharing the same wall with the U pole. Summarizing, yeah. I want to remind you that this topic here, guys, is what medium voltage. Medium voltage, higher than 600 volts. So any rule from now on is higher than 600 volts. Me and you guys work on higher than 600 volts. Anybody higher than 600 volts? Anybody works on, how about NX no? Green chair. Oh, higher than 600 volts. Or higher than 600 volts. Interesting. The full boxes for higher than 600 volts, believe it or not. Number one, for the full boxes, sizes of full boxes, terminus, full boxes, and so forth. For straight pole, and you probably have never seen that one, it is 48 times 40 times the outside diameter or sheath of the largest shielded or leaded covered conductor or cable intended into the box. The length should not be less than 32 times the outside diameter of the largest non-shielded conductor. So 48 times the diameter of the cable entering the box. Okay? So the outside diameter of the largest non, if it's shielded, if it's shielded, they go 32. Oh, sure. If it's non-shielded, you go by 32 times this. Most of them are going to be shielded cables, guys, except a few applications for non-shielded. So you take, here you go, Matthew, you have the cross-section area, your diameter of your cable is, say, 2 inch, multiplied by 48, and that will get you a straight pole. What's this, guys? Here's a box. I pull from here, medium voltage cable from here, and I need to find that distance. I need the distance, right? Okay? To fix that, if the diameter of this was just, say, 2 inches, 2, that will get me what? 450, 90, 96 inches. So that would be 96 inch wide. Remember, we're talking about medium voltage cable here. It's a big box, 96 inches. Cable, 2 inch cable is a big cable. Okay, 48 times the outside diameter. This is straight pole for the box opposite wall shall not be less than 56 times the outside diameter. They increase for additional entries by the amount of the sum of the outside diameter of all other. The same thing. 36. 36 times the diameter plus other diameter. Diameter 1, diameter 2, the other diameter. So pole is coming, leaving, cable 2 coming, leaving, cable 3 coming, leaving. So this one, so let's say this was 1 inch, this was half an inch, was 2 inch. So 6 times 2, 72 plus half plus 2. So 74 plus 2, 74 and a half. So then the box from here will be 74 and a half inch. These big boxes, guys. And talking about any question is about this. So it's interesting how they do it. This for conductors enter in a removable cover. You can go dimension based on 334. 334. Yeah, well, provide bending for the conductors as provide 334. The table that they go to and 334 to find the bending radius for medium voltage. And the straight other than you guys have probably have never seen the 48 and 32. I multiply the diameter of the cable, not do it. Guys, corrosion, resistance, passing through partitions. Passing through partitions should be provided where conductors or cables pass through partitions and at other locations where necessary. What they need: bushings, shields, or fittings having smooth rough edges shall be provided, so they don't bust your cables or compromise the continuity. Shall be made of material and has resistance. So complete enclosure. Shall provide a complete enclosure for the contained conductors, no holes, nothing. Wiring is accessible. You can't go and cover the boxes after you install them. You have to cover them. Suitable capacity in this underground boxes, they have to be 100 pounds, over 100 pounds. Shall considered meeting the requirement, and you have to say high voltage keep out. So you have to mark them with big high voltage keep out, and they are suitable for expected boxes, and their cover shall be capable of withstanding the handling to which are likely to be subjected. So that these cables, you love them and make sure they're going to be there 5, 10, 15 years from the installation. And these pole boxes for medium voltage, higher than 600 volts. The only thing is about them is how they size them. They size them based on the diameter of the conductor, not the conduit like we do in the low voltage, not the conduit like we do in the low voltage. I also did not mention the same. If you have a box, you have angle pole. If you have angle pole, guys, medium voltage angle pole, the same rule. You need to find the distance from here to here. For an pole, it's 36 by the diameter. Diameter 1, diameter 2 is diameter 1, diameter 2. Also, the distance between these two, where between enters and exits, the distance is 36 outside diameter, so it has to be 36 times the largest diameter, which is the said U1. Rule, guys, except the multiplier. If you read it, it's almost in language, just it's not different number. Instead of using the conduit, use the diameter of the cable. And ever installed a J-box medium voltage pull box? Anybody installed a medium voltage pull box? Medium voltage pull box. Okay. Fun to do the requirements and so forth. So then we cover the pull boxes. That's basically it, guys. The only thing I don't think we before we get exercise, we need about handhole. Handholes 14.30b. It's good. A little bit. Okay. Enclosures, handholes 314.30b. Let me see. Okay, 30 holes. A couple of guys in the handholes. Handhole shall be designed and installed to withstand all loads likely to be imposed on them. They shall be identified for the use underground system. Sizes. They have a couple of ways of sizing handholes, guys. Handholes and handhole enclosure shall be sized in accordance with 314.28. So we're doing handholes, and handhole is right in the ground, the handhole. So using it for low voltage, guys, you're going to treat it as a pull box. You're going to go apply the rules of 314.28. 28. There's the rules of a pull box. Insulating it. This is for low voltage. Low voltage meaning voltage 600 or less. High voltage over 600, you need to go to exactly what we were just saying, guys. 314.71. If you have a hole for high voltage, size it based on a pull box for high voltage. And it's low voltage, then size it based on a pull box for low voltage. So, under raceways and cables, assemblies entering a handhole shall extend into the enclosure, but will not be required to be mechanically connected to the enclosure. All enclosed conductors and any splices or termination is present shall be listed as suitable for wet location. Very interesting. Handholes guys on the ground. You brought your cable here. You brought a cable in here. You terminate them. So there could be wet location. This for wet location. As for all manholes, either has to be more than 100 pounds or to have some type of mechanical needs to open it. And it, by the way, it always have to say electric on it. Electric. So when people come, if that's electric, they know that's not water. And a tool unless it weighs more than 100 pounds. So that's about the handhole. Now, as a full box, high voltage or low voltage. Anything else? Any question before I'll let you go with the review questions here? No questions? Okay, let me, I have a couple of polls for you guys, so that will keep you busy for the first time. Really nice questions here. Let me go open the poll. This is questions on this. It's slow here. Okay, let me give you guys 7 minutes. This is 60 questions. I'm going to give you 7 minutes. And go ahead and start. They're really nice. I think they're nice anyway. Thank you. Let me go and share the correct answer. So some of them are really good, guys. And this one in particular that I think you encounter in your exam. The that talks about non-metallic number 6. Metallic sheet cable not required to be secured to a box is if it's coming into a single gang box and it's secured with 8-inch. Very interesting. That one, you always like to do it, guys. So if a box, a single box, and they have cable coming to that box, cable it within 8 inches. Normally, you need 12 inches, right? Inches to the box to tie your device or whatever. Then it needs to support right here to the box. No need for support to the box. Really cool in terms of the exam. In terms of the exam, number guys need you to do some calculation. Also, let me see how everybody does. Got them. Number almost there. Okay. So number 4 requires you like a 3-way switch will be 2, a 12-2 and 12-3 will be 5. Equipment conductor will be 1. Probably some of you missed the equipment conductor. That will be an 8. Then you multiply by 2.25 get you 18 cubicle, and that will be the answer of that one. So a few of the really good. Number 14 also 2-inch conduit for sizing a full box. That was a good one outside the full box. Anything is about any of these in particular? Any question about any one of them? And how about the next for chat? I don't see your chat. Let me know. Okay. Or poll for you guys before I let you go for the night. Is alright, so I'm gonna go and get, well, enough. I'll give you 5 minutes, guys, for these, and just look at them. It's really nice. Listed questions for them. What happened to you, my friend? You cloned yourself 4 times, man. Only. Okay. Right. Oh, let me share the cursors with you. All right, so I'm just looking at the majority of you. No. Boxes be supported. Supporting for seeing. No. Okay. Any guys about any one of these? Any questions? So then another set of things that you probably will lead to. So yes, my friends, I don't have anything in particular I want to mention over here. And we are maybe chapter number 7 talk about pulses for medium voltage. So with this, my friends, as you know, we have covered J boxes, device boxes, pull boxes, high voltage and low voltage, and we did handholes. We did handholes. So hopefully that guys will help you a little bit add to your knowledge in the electrical. Here's what we'll do next week. Next week, guys, we'll be moving to some installation. We're going to spend something in Article 110, and we'll talk, guys, about conductor insulation and sizes and so forth. And then we will move into something very important with equipment installation and dedicated space, working space around the equipment, and dedicated space for the equipment to bring to it and to work around the equipment. That's when we do it next week. We're going to talk about the same dedicated space for equipment and working space around the equipment for the medium voltage, anything higher than 600 volts. Then move into a tunnel, anything over 600 volts, and handholes, enclosures. So that'll be kind of a really nice topic next week, guys. Out of the working space in the front of the equipment, is it 4.5? Is it 3? based on the voltage and the grounding upright directly in front of the equipment. That's basically what the plan for next week. Anybody has any question, guys, about what we covered so far? Any question about what we covered so far? I see a chat here. And I saw you for a while. You were three of you. Huh? I three of you, buddy. So okay. So that's basically all we have, guys, for you tonight. I'm sorry I was a little bit tired, Jacob. It seems to give me a time. My son was sick last night, and I spent all the time with him. I had a good sleep, so I apologize if I was yawning a little bit. I just really tired. Okay, that's all we have for you guys. We'll see you next week. Don't forget that we'll see you next week to talk about electrical installation. Thank you, friends. I'll see you next week. I can hear if anybody has any questions.